Hi, in this session, I'm going to talk to you a bit about surveys. Specifically, I'll talk to you about scaling and measurement issues in surveys. Surveys, as you know, are critically important to support the descriptive research design. They're also widely used in the causal research design. Our focus, however, in this session is going to be on the building blocks of surveys, scales. Let's take a look at what measurement is. It's about assigning a number or a symbol to characteristics of objects. The scale itself is a continuum upon which measured objects are located. There are 4 primary scales of measurement. These span across various disciplines. You'll find these scales as being fairly robust across different, again, domains. A nominal scale is one where every observational unit is assigned a number to identify it uniquely. Think of a nominal scale as consisting of a bunch of identifiers then. The identifier could be a number or it could be a verbal label. As a number, it could be the ID number of the person, the social security number, customer ID number, membership number. All these numbers merely uniquely identify an individual. The numbers themselves, just like the jerseys that soccer players wear, the numbers that football players, soccer players, baseball players wear on their jerseys don't indicate anything about their ability. It is merely a unique identifier, and that's it. Another example would be that of zip code. The zip code somebody resides in is merely a unique identifier to uniquely identify that part of the country. The 5-digit zip code then doesn't itself have any numerical properties beyond being an identifier. Somebody living in New Jersey has a zip code that begins in a 0, while those living in New York have a zip code beginning in a 1. For instance, the place where I live has a zip code 07039. The place where I work has zip code 10038. It doesn't make the place where I work any better than the place where I live. And by extension, it doesn't make the lives of those in New York much better than those in New Jersey by virtue of the zip code number. It would be equally nonsensical to assume that those in California, because those zip codes begin in a 9, like 90210, let's say, are any better than those of folks in New York because of the zip code. Now, an ordinal scale has, properties that go beyond that of a nominal scale. For example, with an ordinal scale, the number may reflect a rank order. A rank 1 is better than rank 2 is better than rank 3. A company might break up their customers into tiers, a platinum, a gold, a silver, and so on. Or a club may have different levels of membership, a platinum membership, an onyx membership, and so on and so forth. These different tiers might reflect an ordering in terms of some people getting more importance than others or being treated better than others. But the difference between these different levels may not be equal. So thinking about a sporting event, the gold medalists and silver medalists are not the same distance apart as the silver and the bronze medalists. To think more specifically, some races are won by a fraction of a second and some by many seconds. It is entirely possible that the gold and silver medalists duked it out where the gold medalists won by 0.01 seconds, while the silver and bronze medalists had a huge difference of about 7 seconds between them. However, when they get on the podium, gold, silver, bronze merely reflects an ordering. It does not convey how close any of the races were. An interval scale is one where consecutive levels are equal. On an interval scale, the difference between 1 and 2 is same as 2 and 3, is same as 3 and 4. Similarly, You think of a questionnaire where people are asked to respond on a 1 to 5 scale, where 1 is strongly disagree and 5 is strongly agree. We assume that 1 and 2 have the same distance as 2 and 3, as 3 and 4, and so on, making this then an interval scale. For this reason, we treat all survey Likert type scales we're going to look at very soon, attitude scales you see on surveys as being interval scales. Some make an argument that these are not strictly interval, but we're not going to debate that. Okay. There is a majority of people that believe these scales are interval. We're going to go with that majority opinion here. And so all your 1 to 5, 1 to 7 scales you see in questionnaires are classified as interval scales, whereby the distance between 1 and 2 is 1/2 of the distance between 1 and 3, and so on. That being said, there's nothing holy about a 1 to 5 scale, as in it could just easily be as 11 to 15. Granted, it sounds a little awkward, but you could also move 1 to 5 back so that you have a -2 to +2 scale. Still has 5 scale points, and it can be the same meaning as a 1 to 5 scale. Bottom line, with an interval scale, there is no origin. There's no absolute zero of the scale. So you can easily move the scale up or back without losing any meaning. Now, with the ratio scale, there is, in fact, an absolute zero. So things like time, for example, time cannot be negative. So if the time is 0, well, that's the smallest possible number. The other beautiful thing about ratio scales is that the ratio scale numbers have ratio properties to them. For example, if somebody took 10 seconds to complete a task, well, then they took half as long as somebody who took 20 seconds to complete that task. Similarly, if somebody ran 100 yards, that means they ran half as much as somebody who ran 200 yards. The same could be said about meters as well. Somebody ran 100 meters, ran 1/2 as much as somebody ran 200 meters. So distance, time are all ratio scales. Now, let's assume today is a 70-degree Fahrenheit day. And, a few months ago, it was 35 degrees Fahrenheit. Would it be fair to say 70 degrees Fahrenheit is twice as warm as 35 degrees Fahrenheit? If you said yes, think about it. That's a trick question. Let's analyze this actually. What we're going to do here is we're going to ask Google's help to do something interesting. You all may know that most of the world except America works on a Celsius scale. So what if we go to a scale that is reflective of what the world looks at? So 35 degrees translates to roughly 1.67 degrees Celsius. And 70 degrees Celsius Fahrenheit translates to approximately 21 degrees Fahrenheit. Celsius, excuse me. So hopefully this makes sense to you, or some sense. This means if you went from a Fahrenheit scale to a Celsius scale, now the ratio is 1.67 to 21, not 1 to 2. This is what I meant by saying, well, think about this one for a bit, because a temperature scale using Fahrenheit is not a ratio scale. It is an interval scale. If you're wondering why, think back to how I defined a ratio scale. A ratio scale has an absolute zero. Interval scale does not have an absolute zero. Because Fahrenheit scale can go in the negatives, it's not a ratio scale. So then, is there a scale for temperature that does not go negative? It's not Fahrenheit. It's certainly not Celsius. Well, there is a scale. It's the scale for Kelvin. So if you were to convert temperature to Kelvin, so 35 Fahrenheit translates to 274 degrees Kelvin. Now the Kelvin scale does have an absolute zero. And therefore, if you're going to measure temperature as Kelvin, well, that fits into a ratio scale property. Okay. You're probably wondering, why are we spending time on this academic exercise of examining 4 kinds of scales? Well, because the scales affect the kind of analysis you can do. Rather, if the data is in a ratio scale format, the kinds of analysis you can do are almost limitless. With interval scale, there are limitations in what you can do with the data, but not too much. You can run regressions, do factor analyses, do averaging, fun stuff like that. With an ordinal scale, the number of things you can do is much limited compared to interval scale. With an ordinal scale, all you can do is look at rank order kind of scales and rank order analysis, ordinal analysis. With the nominal scale data, what you can do is even more limited. So with the numbers, with the nominal scale, all you can do is counts and percentages, and you can do some statistics like a chi-square test, a binomial test, but that's about it. Let's take an example of a nominal scale and see how this makes sense. One example of a nominal scale we've not discussed so far is somebody's gender. To keep things simple, if I think of a binary world, male and female, we now have data on males and females. Now, the scale is clearly nominal scale. It cannot be ordinal scale, because if you thought it's an ordinal scale, then that would make you a sexist. Right? All we can do as far as the analysis is concerned is to look at the number of people who are male or percentage of people who are male or female and compare the two percentages or counts. It's as far as we can do. We cannot even compute an average. Can you imagine computing the average gender or average race of people? It would be nonsensical. Yes, so with the nominal scale data, you can do very limited kind of analysis. With an ordinal scale, you can do a bit more. With interval scale, much more. With ratio scale, even more. Bottom line, if you have the option, try and get your data to be in a ratio scale or interval scale. If you're stuck with interval scale or nominal scale data, you will struggle at the analysis stage. So all the planning for how the data is going to look in your spreadsheet should happen early on, before you gather the data, not after. Now, broadly speaking, there are 2 kinds of scaling techniques: comparative scales and non-comparative scales. In a comparative scale, we ask people to make comparisons between the options or alternatives. In a non-comparative scale, we don't have them draw those comparisons. Right? So in a comparative scale, people choose between A and B. In a non-comparative scale, they evaluate the items in isolation. Cognitively, for the respondent, a comparative scale is easier to respond to than a non-comparative scale. In terms of data provided, a comparative scale is bound to give you ordinal scale data, which, as we know, is going to limit the kind of analysis options available to us. With non-comparative scales, the data we're going to get is most likely going to be interval scale data, which offers us more opportunities for analysis than does ordinal scale data. Okay. So with that in mind, let's examine each one of these types of scales. Now, what we can do here is, to make this a bit interesting, we're going to do this in an interactive kind of form. We're going to examine each scale and implement each scale, all using a very interesting example. So let's take a look at an exercise here that we can do. So here's an exercise. We're going to look at a set of ice cream shops to compare using our examples. So our ice cream shops, let's make up some ice cream shops out here. I'm going to go with Baskin Robbins. Ones that come to my mind right now: Costa and Creamery. What else? One that's hard to pronounce. I don't know if I should do this or not. And Hopefully I spell it correctly. Actually, I'm going to Google this while I'm recording here, just so I can make sure I get the right spelling. Right? So I've got here, I'm going to put Carvel in there and then do Van Leeuwen as well. Okay, so let's go. Oh, we already have. And Van Leeuwen is spelled correctly. Good. Okay. These are the 4 ice cream shops I've got here. Now, I'm not gonna, we'll not bother with putting in the flavors on here. Just for convenience sake, what I'm gonna do is I'm gonna put this into Notepad to strip it of all formatting. I'll share with you why I'm doing that right now in just a minute. It's gonna make it easier to copy stuff into our survey software. Copying those 4 names into a notepad as well. So these are the 4 ice cream shops you're going to work with here. And we're going to construct a questionnaire in Qualtrics to do the following. We're going to compare the 4 ice cream shops using the following comparative scales: paired comparison, rank order, constant sum. And then we can, if we have time, if there's time, I'll categorize them into, 10 using a quick sort method. And then rate the 4 ice cream shops using non-comparative scales. So we're going to look at the comparative scales and non-comparative scales. We'll implement them right now using our 4 ice cream shops. So it's going to be a mouth-wateringly good example, I hope. So at this stage, let's go, and I have invoked the example we're going to work with. So let's dig deeper into that. So here we are back on our slide. I'm going to go over to Qualtrics. What you can do here is you can type in paste.qualtrics.com, which will take you straight to the Pace University Qualtrics login service. Okay, so again, just note what I did here. I typed in paste.qualtrics.com. That's what you want to type in. I don't want you typing Qualtrics.com and setting up a free account. That's not a good idea for what we're going to do here. Now, when you type in pace.qualtrics.com, it's going to take you to this page where it's going to ask you to plug in your Pace University credentials. Okay. Now, I'm not going to be able to replicate the environment you're going to encounter when you get in. So I'm not going to be able to do exactly that. You got to figure out a little bit about this on your own. As soon as I hit the login button, it'll take me straight to Qualtrics, to my Qualtrics account. My Qualtrics account is already set up. So I'm not going to see the same information that you would normally see. Now, if you sign in, username, password, go in, the Pace username, password, and go in, you will then be asked to register your account, do the needful, and eventually you will have an account ready. Okay, I'm going to assume you will figure this part out. Okay, now here's what happens when I click on paste.qualtrics.com. I get sent straight to my Qualtrics page with a number of surveys already in here. So this is what you might see when you get to your starting page. You may not have any projects at all. I'll click on create a new project here to get us going. Okay. This is probably what you're going to see when you arrive and have everything logged in and set up with Qualtrics. As you're setting up your account, if you're ever asked for your email address, make sure you provide your base email address only. Qualtrics is a very pricey, high quality, state-of-the-art survey software. There are many survey software out there, and I have used many of them over the last 20 years or so. I've even programmed my own survey, created my own survey in HTML and JavaScript many years ago. And trust me, it was a nightmare. It was a lot of work to do something very simple. Qualtrics makes survey implementation design extremely easy. It's a very functional software with lots of bells and whistles and lots of automatic shortcuts and templates built into it. Okay, I think I've sold the software to you. Well, I don't have to sell the software to you because it is free for you. Your Pace tuition covers access to Qualtrics and all the surveys you can make out here. And trust me, I'll just say this one more time. This is way better than Zoomerang, SurveyMonkey, or anything else out there that I've ever seen. Okay. So when you click on to make a new project, it's going to ask you, what do you want to call your project? I have lots of names out here. I'm going to say demo something, okay? You can call it whatever you want to, and I'm just going to say demo. And if you've got a lot of, you may not have any folders if it's your first project ever. In my case, I have a lot of these surveys I keep making, so I'm going to put them into some place here that I know is so let's say class demos one. And it's asking me if I want to use what I want to use to start my survey. Blank survey project is fine. I'll say create project and get us going. Now that we're in here, this is the Qualtrics survey interface. What I'm going to do here is I'm going to go into Qualtrics and I'm going to build a survey. We're going to learn as we navigate through how the survey software works and also learn a little bit about scales and all the time think about ice cream. So we have 4 ice cream shops we're comparing out here. Let's begin by going back to these slides. What is a paired comparison scale? A paired comparison scale is a kind of comparative scale wherein you compare pairs of products, attributes, what have you. So here's what it looks like then. If you've got 3 brands to compare, you will ask people to choose one or the other brand. Okay, so select the brand you prefer, brand A or brand B, and brand B or brand C or brand A. Okay. Let's go and do this. I'm in the Qualtrics right now. First, let me define here the block name and call this a paired comparison scale up here versus block. And I've given the block a name. Naming a block helps organize your survey and also creates a natural page break in your questionnaire once you're done. These numbers won't show up in your actual survey, so ignore them, but they're good to kind of keep track of what your questions are. So the statement number right here is pick the ice cream shop you prefer. And the options here are, we only can put in 2 at a time. So they're going to be, I'll go with Baskin Robbins. And then I'm going to just hit, I could either click out of here and click into the choice 2, like I'm doing here, or I could have hit the enter key. Either one would work fine. I have 3 options here. I only want 2, so I'm going to hover over option 3 and say remove statement. Remove choice, excuse me. Now, I finished creating my first choice out here. As it stands right now, this question would look as follows in the actual survey. I can preview the question and see it looks like this. Now, when you're building a survey, you got to keep in mind that there's only limited screen space available. So you want to put stuff side by side if you can. So I'm going to say alignment horizontal. And that's going to save me some valuable real estate on the screen. Here we are. Pick the ice cream shop you prefer. Baskin Robbins or Cold Stone Creamery, and we have them side by side now. Okay. And now what I'm going to do is I'm going to create, because we have 4 ice cream shops, right? A little bit of math out here. If you have 4 ice cream shops or 4 things you want to compare, you've got to think about how many possible combinations you can have. A good analogy to think about is, if you're thinking about a football conference, there are typically 4 teams in the NFC East, for example. Think about how many possible games they can play with each other. It turns out that number can be figured out as 4 chooses 2 or 4C2, which comes to 4 times 3 divided by 2, or that's 6. Don't worry, that bit of math I've shared here in the slide as well, if you're kind of wondering how you figured that out. If you have 4 brands to compare, that's going to require 4 times 3 divided by 2, or 6 pairwise comparisons. So we got to build them all out here. When you're building a survey, as far as possible, you want to copy stuff, because whatever formatting you did earlier, you want it to be consistent from one question to the next one. So I'm going to copy a lot of stuff out here. To copy a question, all I got to do is go out here and say copy. In Qualtrics, copy will do copy paste simultaneously. So if you say copy here, bingo, gives the next question right below it. I'm going to hit copy a few times out here, actually 5 times. So because then I'm going to have total of 6 questions here. And here's what it looks like. So now I'm going to go through painstakingly plugging in every one of these other options. You're probably wondering, why am I even doing this painstaking work out here? Because I want to make a point out here. The point is that Qualtrics is super easy to edit. Right now, I'm just copy pasting from my notepad in here to save some time. The second point I'm trying to make is that excuse me, Coldstone Van Leeuwen, is that a paired comparison scale is painful to construct. To get people to evaluate 4 ice cream shops requires asking a lot of questions. 6 questions, that's a lot. So something simple requires a lot of questions. The beauty of this, of course, is that paired comparison scales are like that, historical classic example of the Pepsi challenge, having people choose Pepsi or Coke in a blind taste test, right? People find it extremely easy to evaluate brands that are pairs. Let's choose one or the other. It's cognitively easy to do. I've now gone preview mode out here, and you can see how this works. You can choose ice cream shops very quickly, and you can go through. Hopefully, I got all the ice cream shops in correctly, and we have 6 questions to evaluate 4 brands. So one of the downsides about a paired comparison scale then is the fact that you got to ask a lot of questions for just a few things you want to compare. So let's go into another format that might be a little easier to utilize. This is the ordinal or rank order scale. A rank order scale has respondents rank order items in some order or some manner. So I'm going to go add a new block here to separate, because now we're going from a paired comparison scale to an ordinal scale or rank order scale. So I'll call this a rank order scale. And then here I'm going to add the question, which is, I'm wondering what it would be now. When I hit add a new question, it offers me some options, including multiple choice, text entry, and there's rank order. Perfect. So we'll just add some script out here. Please rank order. Please order the following ice cream shops in order of preference. Obviously, is it descending or ascending? So we'll say descending order of preference. Just to be clear, most preferred one on top. I always like to use simple language in the survey. You always want to make sure that the least smart person taking your survey understands the question. Now I'm going to leverage that those 4 ice cream shops I copy paste in the notepad. I'm going to simply click somewhere here and hit paste. That's going to paste all 4 ice cream shops right there for me. So here we have it. We've got a rank order scale. That people can rank order easily. Let's see what it looks like. I'll preview this question. Here we have it. Very easy to do, right? I like Coldstone the best, and Baskin Robbins is good. I think Carvel will come forth for me. Okay. We move on now to another kind of comparative scale. This one is called a constant sum scale. In a constant sum scale, respondents allocate a constant sum of units to all the elements of they're evaluating. So let's see how you'd create a constant sum scale here. So I'm going to do 2 things here. I'm going to add a new block, call that new block a constant sum scale. And next, I'm going to make a copy of the previous question that we will modify to convert into a constant sum scale. So we'll copy this over, again, copy. When I copy, this question appears right below the previous question. Now, I actually want this to go to the block below. So I'm going to go over to, okay. There used to be an option to bump it down. I don't see that option anymore. Not bad. Okay, so I'm going to drag this and move it down to the next level. Hopefully it allows me to do that. It didn't work out so well for me. Okay, there. Okay, so I've moved that question that I copied to the next block called constant sum scale block. Now here, I'm going to put a little note out here which should explain exactly what a constant sum scale does. So please allocate 100 points across the following ice cream shops. To reflect your preference. Most preferred gets the most points. Okay. So we want to limit them to 100 points. So now, of course, this scale, I've changed the statement out here, but it's still a rank order scale because I copied it from above. So what I need to do here is change the format of the scale right now to one that is a constant sum scale. Obviously, since I copy pasted the scale, I've got to edit the scale. There's no option here to edit the scale type. I'm going to go over to the left then and look for the question type option to edit this then. And here I can see there are many options, including the constant sum scale. Now, when I go to constant sum scale, I get by default these boxes that look ugly in my view. So we're going to go with a different answer type option. We'll go with some bars to look nicer. And we'll go with, let's do something here to do a custom start position. So we'll put them all at 25 to start with, I think. And we'll also set here a validation. Okay. So we say add validation, say must total to 100. That looks good, I think. Let's take the grid lines look ugly, I think. So I'm going to minimize some of the grid lines there. 5 grid lines is enough. Okay. So here we are. Let's preview the question. Here's what it looks like. When the respondent goes in and looks at this question, they can now allocate 100 points across these 4 items. Now, one thing that people don't like to do is do math in general. You probably can relate to that. The last thing anybody wants to do when filling out a survey that they're wasting a lot of their own personal time doing is to have to do math. So we want to make that process as painless as possible. So we want to minimize the amount of math somebody has to do. So the validation then ensures that people don't cross 100. And they're exactly doing 100 points across those 4 ice cream shops. The beauty about a constant sum scale is it forces trade-offs. For certain products, just inherently likable products, one is going to be predisposed to just give, say, I like them all. With a constant sum scale, we force people to make difficult choices. If they score Cold Stone really high, like I am tempted to do out here, I realize that now I must score Baskin Robbins lower. Not now, like saying, okay, so what do I do here? Okay, I got to give Baskin Robbins some more, and then a Carvel gets the least. That's what I want to do here. This is another example of a comparative rating scale. Okay, let's move along now from these comparative rating scales to a non-comparative set of scales. Non-comparative scales involve rating items in isolation without concern or consideration to the other elements. So let's see what that looks like. Okay, so a non-comparative scale, amongst these we have continuous rating scales and itemized rating scale. Let's begin with the continuous rating scale. A continuous rating scale is one where you can place the mark anywhere you want to. So let's see what it looks like. This is an example of a continuous rating scale for 4 brands A, B, C, and D. Let's try to imitate this using ice cream shops in Qualtrics. Add a new block. We're going to call this new block, you guessed it right, continuous rating scale. And we're going to make a copy of our previous question and move that down. We'll modify it once we get into this realm. Here we are in this area. So I'm going to say, make a note out here. Our note is going to say something similar to what we have in this example. So it's going to be, please rate ice cream shop higher numbers indicate higher rating. That's kind of obvious, but I'm just leaving that in there anyways. So right now, this is going to be a constant sum scale. Let's modify this to be a continuous rating scale. So let's find that option. The option is called slider in Qualtrics. And the answer type is a bar, but that may be confusing. You might confuse that with a constant sum scale. So I'm going to make this a slider, right? So it looks a little different from that. I'm also going to, by default, I don't know why Qualtrics puts these labels on top, and just delete those manually. So click on them, very user-friendly software, the down arrow, remove label, and it looks cleaner. And again, I'm going to make the number of grid lines out of 5. I think it's sufficient. And that's it. So here's our continuous rating scale then. Here's what it looks like. And people can, of course, choose to rate high, low, and so on. Of course, the downside about this is people are going to rate everything high as opposed to a constant sum scale where there are constraints imposed because they have to make trade-offs. Now, one of the downsides about continuous rating scales, one of the good things, it's easy, it's simple, it's a slider scale. People love having options to choose from. The reason these are not popular is that, this is 62, or it's closer to 68, 16, 70, 71. Now, the question people often ask about continuous rating scales is that, are consumers' preferences so granular, so clear that they know the difference between 71 and 72? Now, if you don't feel that people have such granular, cut and dry preferences, then maybe our scale is not reflecting their mental sort of schema when it comes to rating, evaluating things. And so having a 100-point scale is no better than a 10-point scale then. That's the criticism of using continuous rating scales. They give a false sense of accuracy to the researcher, which gives way to then the most widely used scales in surveys, which are itemized rating scales. Itemized rating scales are marked by the fact that they have a set of items that are rated on a 1 to 5, 1 to 7 type scale. Amongst these, the most popular scale is the Likert scale. Some people call it Likert, but I think it's actually, the person's name is Likert. Here we have an example of rating of satisfaction on a scale for brands A through D. We're going to do the same thing here, create our own Likert scale using our brand. So as before, I'm going to keep copying stuff and moving it below because it's going to save us some time. So this time it didn't work out so good. Let's try again. They call the new block a Likert scale, and have it. So please rate. So now I've got to come up with a statement here that would be meaningful. Let's just say, please rate each ice cream shop. Let's keep it as simple as that. And now we have to decide what we are going to use as our scale for Likert scale here. Please rate each ice cream shop. This does not look very interesting. It's not a Likert scale at this point. So what we need to do here is define this as a Likert scale. To do so, we're going to use the matrix format of questions. Here's the matrix table format. When you hover over it, Qualtrics shows you what a sample would look like. And there you have it. We have now a typical questionnaire type scale. Granted, it only has 3 points right now. Don't worry about it. We'll add more points now. The question is, what do we have out here? Now, it might be tempting to go and click here and edit in here something like not at all, like a little bit, neither like nor dislike, so on and so forth. I would encourage you, or discourage you from doing that. Never try to edit these scale points because it ruins the formatting that Qualtrics has going on in the background. And once you manually make edits, Qualtrics can't fix that. Things look out of order, so don't edit. Instead, we'll use the suggested scale points option on the left. If I turn that button on, I get a whole bunch of options, and by default, Qualtrics has added in a disagree agree scale for me. Now from here, I'm going to choose one that makes more sense. Rating ice cream shops, disagree agree doesn't make sense as anchors, so bad to good could be an option. I could do dislike like, perhaps. This makes more sense. Okay. Here we have a scale then, a 1 to 5 scale, indicating dislike a great deal to like a great deal. I'm so happy that Qualtrics reversed its scales to have negative first and positive later. In previous versions, it was the exact opposite, and I hated it. So I'm glad they fixed that. If you want the middle options to go away, you can always select the show first and last. It makes the scale look less busy. But I wouldn't do reverse order. This is the way it's meant to be, and leave it just the way it is, where the left is the negative and the right is a positive, not the other way. So here we have a Likert scale created to rate each ice cream shop. Likert scales are the most widely used rating scale out there. You can, of course, play around with this if you'd like to. Go to a 7-point scale, and so you get the anchors coming in automatically. Hit the negative button, go to 5 points, go to 3 points if you'd like to. You have that option available. Okay, that's a little bit about Likert scales. Let's move along to graphic slider scales. These are beautiful scales. They're beautiful because they just make it exciting, interesting to fill out a survey. So let's see what a graphic slider scale looks like. A graphic slider scale is simple. We'll add a question out here. I'll choose from here the graphic slider scale. Our ice cream shops begin from Baskin-Robbins to Coastal Creamery to so on. Here's Baskin-Robbins, and I have the option now of choosing a different gauge for my graphic slider scale. The default is this gauge that you're seeing in front of you. We can always go to something else, Baskin-Robbins thermometer maybe. That looks nice. Or you can assign a grade, play professor if you wish to, right? So let's do that. Let's play professor out here. We'll keep it simple, not go with A+ and A-, with A, B, C, D. And so now you have the option here of rating every ice cream shop using this scale. As I've done before, I'm going to copy this over 4 times because I want consistency in my scales. So instead of Baskin-Robbins, the next one will be Coastal Creamery. Now, I am going through many of the defaults, leaving them just the way they are. You can tinker with many of the options available. I don't mean manually editing, but there are many options that Qualtrics will allow you to modify out here, like a slider position, text position, so on and so forth, to make it look the way you'd like it to look. So let's take a look at one of these scales, what it looks like. This looks like the following. So here's the scale. Again, people can rate the ice cream shop from A to D, I believe. Okay, our last scale is going to be the semantic differential scale. Here is the semantic differential scale. Semantic differential scale is typically used to rate things on what are polar opposites. You typically use it for a given brand. Let's say you want to rate an ice cream on taste, price, and being healthy. So what you would do then is you'd rate every ice cream shop on those different options. The semantic differential scale looks, let's take a look at what it looks like here before we go any further. Here's what it looks like. It involves giving people polar opposites to choose from. So here we are. Please rate each ice cream shop. Please rate, sorry, Baskin Robbins on the following attributes. Or you can say Baskin Robbins is, and then you have the polar opposites coming in. We're going to use your taste, price, and health. So we'll use our polar opposites. We want to use a not Likert scale, but use a bipolar scale. So I'm going to go in here and say Baskin Robbins is, I'm going to use taste as my example. So yucky and delicious. And the other attribute is price. So expensive, inexpensive, and last one we're going to use is healthy, is unhealthy and healthy. And we'll add some more scale points out here if you think that it's appropriate. 5 points maybe it's better than 3 points. And so here's a semantic differential scale, which helps to place this polar opposites out here. We can repeat this process for all our brands. So we do this for Cold Stone and then again for so Cold Stone Creamery is, and then we'll do this for Van Leeuwen, and then for lastly do this for Carvel also. Okay, so we're done here with the survey is ready to go. We can do a little bit of a checkout here, hit the publish button, and it's going to tell us, well, expert score is telling us this is a good looking survey. Now, when you're done with the survey, here's what you do. You hit publish, and then it gives you a link. This is the anonymous link, which you can share with anybody for completing the survey. It's also the link you will share with me for an assignment. So if you were to now paste that link into your UI up here, the link I copied, that is, it's going to show up the actual live survey to me so I can see what it looks like. There we have it. Right? So it looks pretty good, right? And there we have it. And there you go. Okay. Now, what you don't want to ever do or submit is give this to somebody, because it's not going to work for them, right? Never use that. Always use the URL that you get from Qualtrics. If you didn't get the one from the published link, click on distribution, an anonymous link, and pick up the link from there. That's a link you submit to somebody, or share with somebody, and they can complete the survey and share back to you. And I mean, you get the responses that they plug into the survey. Okay. So one last thing, oftentimes there are times when you may have to, somebody might say, well, give me a printout of the survey. One way you could do that is go to reports, sorry, distribute, no, sorry, I'm all over the place here, sorry. I'm in survey mode here, and we go to tools, import, export, print survey, and then a window is going to pop up. In that window, you're going to say save as PDF. You say save as PDF, you'll be able to save the survey, which you can then share with somebody else if they want to see a PDF or printout of what the survey would look like. Hopefully this was an enlightening process. You've learned, we've gone over, to quickly recap, the different kinds of scales. Broadly, we looked at nominal, ordinal, and ratio scales, and we looked at their implementation of comparative and non-comparative scales within Qualtrics while understanding what the scales involve or entail. I will continue a discussion about the various scales in a later video. Thank you so much for joining me.